Good morning, everyone. I hope you got outside and enjoyed the sunshine yesterday. New unit today starts stoichiometry. I hope you have read the stoichiometry notes that I attached here. Watch the Bozeman science video as well. I guess the order doesn't matter. Here's a chemistry question. What mass of oxygen is required to consume 20 grams of propane in a combustion reaction? All right. The first thing that I need is a balanced chemical equation. Now, propane is not an ionic compound that you know how to name, and I wouldn't give you one like that, but propane is C3H8. Whoops, I'm starting over again. C3H8 and is a gas. All combustion reactions require oxygen, and the products of combustion are carbon dioxide and water vapor. Now I need to balance this equation specifically to know what is the mole ratio between propane and oxygen. I'll balance oxygen last. 3 carbons in propane would produce 3 carbon dioxide molecules. 8 hydrogens in propane, I will need 4 waters. And if I add up my oxygens, I have 6 plus 4 is 10 oxygens. So I would need a 5 here. This is important in the middle step. Propane and oxygen react in a 1:5 ratio. I'm going to write down what I'm looking for. I want to solve for grams of oxygen. I'm going to write down my given information, 20 grams of propane. And this is going to be 3 steps then. Into moles, moles to moles, out of moles. All right? Watch how the units go. Grams of propane has got to come down here. I'm going to go to the periodic table and add up 3 carbons. 12 times 3 plus 8 hydrogens is 44. 44 grams of propane is the equivalent of 1 mole of propane. I don't have a mole of propane, all right? I have less than a mole, but I still need to convert into moles so I can use the balanced equation. This unit then comes down to the bottom, and I'm going to say moles of propane, and I want to convert that to moles of oxygen. According to my balanced equation, they react in a 1:5 mole ratio. Into moles, moles to moles. Now I'm going to go out of moles, and I say 1 mole of oxygen is the equivalent of 32 grams of oxygen. All right? Into moles, moles to moles, out of moles. Take a look at the pattern of labels. Grams of propane cancels. Moles of propane cancels. Moles of oxygen cancels. And I'm left with grams of oxygen. To do the math, I'm going to type in 20 divided by 44 times 5 times 32. And my calculator says 72.7 grams of oxygen would be required to react completely with 20 grams of propane. We could also calculate the amount of carbon dioxide and the amount of water produced if that was the question. Maybe we'll do that tomorrow. Hope this finds you well. I hope I see some of you at office hours tomorrow. We're all in this together. Keep your stick on the ice.